Tonight we have with us an exceptional speaker who has over 20 years designing and developing high-performance web-scale infrastructures. Please welcome the co-founder and CTO of Aerospike, Bulkowski.
Hi. So how many of you have come to an Aerospike talk in New York before? Okay, a couple, great. So what I'm going to do is I'm going to spend a few minutes talking about Aerospike and what Aerospike is and the things we've done, but hopefully about 5 minutes. Mostly I'm going to talk about some of the advances in Flash. Aerospike is a Flash-optimized database, so not just being RAM and in-memory, we do that too, but we've also found ways to unlock Flash's true potential as a database. And I've also invited today a guy from SanDisk, because some of the products that have come out in terms of new density are frankly almost hard to believe. So I wanted to give him a chance to show you guys what is actually possible in today's Flash with new densities. So what's Aerospike? We've been around. We originally did our first code in about 2008. We're a distributed database. So we focused on key value store operational problems. So instead of going after analytics, column store, a lot of that stuff, we said, if you want to have a front-edge database that is really reliable, really, really fast, maybe it's a little hard to use, it's key value, it doesn't have a super number of indexes, doesn't have SQL, we thought that was an interesting problem to go after. So in 2011, we got our first funding. We're funded by NEA as one of our companies, just like Mongo and MapR. We've added indexes and analytics, and in 2014, we open sourced. So we're now an open source database, and so all of the speed and features for developers are in the open source version. You can find it on GitHub. We have some enterprise versions and under an enterprise license. What we've done in Aerospike is we've found the following use pattern, primarily within advertising technology companies. So in the front edge world, where you have an app server, and the app server is actually doing most of the computation. One guy I was just talking to said it's not analytics, it's analysis. So imagine the bid cycle of ad tech, where you have to compute and you have to try to figure out recent behavior, user profiles, what's my expected value of a particular ad. You've got a lot of computation that occurs up in the app server based on recent behavior, based on segments, etc. And these databases have to be really fast, usually in the area now of 1 to 5 million transactions per second for a lot of ad tech systems, and also have to be low latency, with average latencies around 0.5 milliseconds and going down into the 100 microsecond range, and also have to be in the 1 to 20 terabyte range. Now, those are our larger deployments. We also have smaller deployments. It's open source, so you can actually use it for any project. We're similar to Redis in that way as an in-memory database, but we also have a lot of clustering. So we have, this is a selection of our paying customers. As you can see, very heavy in ad tech. We also have some financial services customers now. One of the reasons I'm out in New York for this particular trip, but I can't actually do their logos, right? Financial services companies, you guys all know, take 2 or 3 years to actually go through their POCs and deploy for large companies. So I'm not at liberty to put their logos up yet, but we're doing a lot of work with that. Compared to Redis, and I know that question about Google Compute, those guys were using batch mode, and we don't. So when we did our benchmark and we hit that number of servers, we weren't doing batch, which I would consider cheating for that benchmark. But anyway, we find ourselves usually a bit faster than Redis on a server-by-server basis, except we have clustering in Flash. The system is clustered for high availability, so you can just add in extra nodes. There's no node controller, there's no shard manager, and there's no sharding at all. So it's a self-organizing cluster that also allows you to do things like geographic replication. So in cases of real high availability, where you need to be East Coast and West Coast, you can set up 2 clusters that will automatically keep each other in sync, even though the long hauls. We have a lot of clients, because a good database is pointless without great clients. So we have native clients or C wrappers for all of these languages on this list, including integration with a lot of the analytics frameworks. So we're not an analytics database. On the other hand, we integrate with the different analytics systems. So that's Aerospike. Hopefully that's given you a flavor for it. If you want to just download it, try it out, etc., that's one of the reasons we're here. We work great in cloud deployments as well. So one thing that I've been seeing now in financial services as we've been engaging is a particular NoSQL pattern that's arriving with fraud detection. So what used to happen with fraud detection was they would write programs that would execute rules in SQL. And so these rules would be things like, if I see two transactions that are too far apart geographically, then the fraud score goes up. So there's a broad variety of rules, but they would usually be written in SQL or reduced to SQL and then actually run in real time, because you have about 50 milliseconds to 100 milliseconds to actually make a fraud score if you're in the middle of doing a money transaction. You have about that amount of time. Now you can always back it out later, right? There's a number of ways to do that, but if you want to try to actually interdict fraud right during the transaction, you've got 50 to 100 milliseconds. So these rules, when executed in SQL, aren't very flexible. And so the companies that we've been working with say, well, wait a minute, why should I write a big Java program that emits a bunch of SQL, and then the SQL executes, and then has to call a database? It's kind of complicated. All of the new algorithms, such as machine learning, are written with Java libraries directly, and they don't emit SQL. They do things like key value lookup, right? So if you're using something like MLlib, you're using something like Spark, those things don't emit SQL. They work on their own in-memory database, or they call out to key value systems. They do not use SQL. And so in the fraud case, it's a very different use case from a lot of the traditional banking cases. In traditional banking, you say, I've got a table of accounts, I've got a table of this, I've got to do bookkeeping, and tables make sense, and SQL and the relational model makes a huge amount of sense. You're modeling a business process in a relational way, and you have to have consistency guarantees, et cetera, et cetera. Fraud's different. In fraud, the name of the game is stay ahead of the bad guys. You're not writing a business process for the ages. You're just trying to find whether this transaction is a good guy or a bad guy, right? The lifetime of this code is much more like a capital markets case where I have actionable data and I'm going to use it now. I found that there's bad guys following a particular pattern. I got to use it now. I'm not going to spend a lot of time trying to model a business process. And so these guys are learning that if they switch from SQL into NoSQL, then they can gain time to market, which is to say, put actionable algorithms in play faster. So take, for example, machine learning. So anyone here dabble with machine learning yet? So it's all about features, right? You got to figure out which features are actually actionable, which are noise for the business problem you're figuring out. So you've got a whole bunch of back-end work to try to run through and back test and figure out your feature set. And then you're going to use libraries in real time that actually compute through your feature set. Not a lot of SQL there. And if you want to use the cutting-edge libraries that really work and have been shown to work, it mates more properly with a key value system especially, as well as a NoSQL system. So if you want to stay up to date and actually build cutting-edge systems for doing things like fraud detection with machine learning, you actually want a NoSQL system, not a SQL system. So I was going to walk through a simple example of this, which is IP addresses. And it's a case that I've been seeing a lot in a number of our engagements. Now I can't go into detail, obviously, about the particular algorithms of the different companies we're dealing with. So this will have to stand in, right? You'll have to make up your own examples of different features, different machine learning systems, different rules that work better in SQL, in NoSQL. So 2 to 4 billion addresses. So that's the number of objects we're going to have in the database. We don't know how many networks, though, right? Because IP addresses and networks, they don't quite line up. Different risk models, but you also want recent behavior. You need to fit recent behavior according to your model to figure out the score of a particular network or a particular IP address. That's the game that they've been thinking. So how would you do this in SQL? Okay, great. I've got a table. I did a back-end calculation. I've been looking through recent behavior. I'm ETLing essentially out of my data lake, out of my Hadoop system, because I see what's fraudulent. I'm looking for packet patterns, and I'm jamming it in a relational database. Looks pretty simple, right? I've got a nice little score table, I've got start and end, and then I've got greater than, less than. So the SQL guy says, yeah, this is great. This is a good use of SQL. On the other hand, you're doing a range query. And range queries actually don't distribute that well. You will not tend to get sub-millisecond response time out of this kind of query with any kind of system. Key value is where you're going to a particular server in a distributed system, and you're going to have low latency. So this is nice and simple. On the other hand, it's not going to match the performance that you get out of any key value system. And besides that, we didn't record recent behavior. So what are we going to do with recent behavior? Well, okay, so now I'm going to have a table maybe that looks like this, right? I've got individual timestamps, I've got different behavior that's being recorded, and maybe I just use the IP address. But then I have to map IP addresses into networks. So now I'm going to have this huge table with a huge amount of behavior in it, and I'm going to do some pretty heavy-duty selects just to pick out the behavior I'm looking for. And, okay, great, SQL does everything. On the other hand, this is going to be kind of slow. And at this point, not being a SQL wizard myself, I call it DBA. The DBA says something about partitions, and we're going to do something crazy about how to do this, and we're going to make this all go faster. Okay, great. What would all this look like in a NoSQL database? Well, you're going to have to roll a little bit more of your own, right? So what if you just, we have domain knowledge about how IP addresses look, at least IPv4, and so let's just try doing everything on class Cs and put together a list of networks under a particular subnet. And then, since it's NoSQL, I can have a list of things in a particular thing, or even say a Postgres, of course, which supports some of the NoSQL syntaxes. And now, what I can do is, when instead of trying to do a range query, I can look up, well, one hop to get a list of networks, network 1, 2, 3, and then another table that has things like start and end IP address. So your app looks messier, right? It didn't have that clean look of the SQL solution. On the other hand, I'm now doing a series of key value lookups. This is going to be a lot faster. It's going to be more predictable. I know how this is going to perform, and it's going to perform really, really well in a distributed system. But now what about behavior? Well, behavior is going to look pretty easy in a NoSQL system too, because I have the ability to put collections in here, right? So for every network, when I get if I get a new event, which I just took, I can actually just add something to a collection, and I can specify this collection as Mongo calls it, a capped collection, and I can limit the size of it, or I can have a process that goes through and prunes out these collections. So what now looked really messy in SQL is looking a lot simpler in NoSQL, and again, based on key value paradigm. So SQL guy says, now this is really messy. I probably had to write, I don't know, maybe 50 to 100 lines of Java code here instead of one simple SQL statement. But it is going to run fast. But then the SQL guy says, yeah, fine, we don't have to use select, we can just use key value. I mean, SQL supports key value. I can do everything with primary key lookups. But really? I mean, why do that? If you have NoSQL systems that are literally 100 times faster for key value use cases, it's probably best to use that kind of tool if you're going to go through the effort of switching over your application paradigm to something like that. Why use SQL at that point, especially when enterprise SQL vendors charge a lot of money? So one of the main things about this is, since the cutting edge systems for this analysis, forget analytics, but analysis, they're all written in Java for the most part. A lot of them are. Datto is a company I really like. They used to be called GraphLab. They're a sister company of ours by Investor. We've done some work with California road traffic. There's a lot of these sensors in California roads. And using Datto's system, we were able to create a predictive machine learning model that allowed us to detect accidents on the California freeway within about 15 seconds. So the question is, when you start seeing a slowdown on a sensor, is it an accident or is it just the normal ebb and flow of traffic? And with the data guys, we were actually able to do that. It's a combination of about 3 features and about 10 minutes worth of data. It's a pretty interesting model, but you're gonna do that in Java, right? This isn't a SQL style problem. So what have we just done here by going through the NoSQL thought process for the kind of fraud problem that modern financial institutions especially are saying? Remember that ad tech case? What we're really doing here is we're creating a compute tier that is the application server. We're creating a storage tier, which is the database. And there are only 2 tiers. So instead of creating an application server tier and then a database tier that is primarily CPU and compute limited, 2 compute tiers, and then creating the lower end of the database and then a storage tier, we're now really separating out very cleanly compute from data. The compute is in the app server, the data is in the database. The database is not doing almost any CPU, unless you want to do, there's some cases where you do want to do a little bit of filtering here and there, some sort of dumb stuff. But you've created a really nice, clear model for being able to write your code at this compute tier in a language that makes sense. That is the language that whatever your team likes. Met a Go guy here. I don't know where he's. Go is a great language for doing a lot of this stuff. A lot of the languages in Java are good. There's great tools in a variety of languages. And so having this compute tier be more flexible is one of the real benefits of NoSQL. But then you need a storage layer. And this is where, with Aerospike, we have found that by having an extraordinarily reliable and fast key value system, this primary key access is supposed to be fast, right? That's really a different paradigm for doing these kinds of things. And these enterprises have started figuring out how this works. And this is where we start getting into, why do I need petabyte key value? So in multiple engagements I've had in financial services in the last few years, I've found this particular profile to be what the leading edge transaction processors are using for NoSQL. For fraud detection. What they need is 10 billion to 50 billion objects. They need about 300 terabytes before replication, 2 million transactions per second, 50 milliseconds is the fraud detection time, and they need local and remote domain replication. So 300 terabytes before HA replication gets you up in the 600, but then you need overhead, call it about a gigabyte, which is why I was calling this the gigascale, right? So if you were going to take all this and try to put it into an Exadata system, which is what a lot of the guys I've talked to are using, the price is a little high. Let's just put it that way. You got to write a lot of zeros in that check to try to build a system like that. So not only do you have the problem that it's hard to write this stuff because you have to take your algorithms and translate them into SQL and you can't use modern libraries, you're actually paying a lot of money, tens of millions of dollars, for the privilege of translating everything into SQL. And I find that kind of extortion, that bugs me, which is one of the reasons why we've created Aerospike. So one of the points about this, and especially when you're talking about 2 million transactions per second, that's very random, right? You get a particular IP address, then you get another one, then you get another one, you get a user cookie, a user behavior. It's all over the place. The ability to do any kind of streaming or batching doesn't work. So these are really random transactions, which is what Flash does well. So trying to put together a petabyte of RAM is a little expensive. And this is where we believe that you can satisfy this kind of workload very, very easily with MLC Flash. Even a year ago, MLC Flash was at a much, much higher price point than it is today. So this has really just happened through the end of this year and the beginning of this year, last year and then into this year. We put out a white paper about using a particular pattern of hardware deployment that I called wide fast SATA. And so there was a lot of people out there selling PCIe cards But what you actually find in a lot of low latency cases is if you have a lot of drives and you really spread the load well across them, so each one is doing a little bit of work, SATA works really, really, really well. And so a majority of our large deployments that are working at, say, 500,000 TPS per server in a large cluster are actually using things like 16, 20, and 24 SATA drives in one 2U chassis. And they're able to get the kind of performance I was just talking about. So there's a number of different flash vendors working in SATA. We do have some people working in PCIe. PCIe, I think, will come into its own probably in the next 6 months to a year. There's some issues right now about availability of chassis that actually allow you to put enough PCIe in a box. But that's starting to get solved, and we'll talk about that a little bit. So here's what in-SATA, in-chassis solutions look like for actually putting together a petabyte of flash. How much space are you going to need? How much speed are you going to get with common stuff? So first of all, let's take a drive that's a favorite of mine. Intel's done a very great job between the major manufacturers in performance over the years, last few years. They have a new one, a PCIe card called the 3700, which currently comes in a 2 terabyte capacity. So you can buy a 3U server, I didn't put that up here, and at about $2 a gig, this is what that server looks like, you can then put about 20 T in one server. So that's 3U. Now that server can run Aerospike, so you don't need extra servers, right, because it's already got CPUs for it. And you'll actually get a huge amount of throughput by putting 10 PCIe cards in a chassis. You'll get greatly in excess of 1 million IOPS per server, and you've got a cluster. So you probably put 40 gig networking on a thing like that. We've tested Intel drives of this capacity with our database software and gotten some pretty great results. But you've only got 20 terabytes, right? So you're going to need a lot of U's to actually stack all this stuff up. Now the good news is at least you've got flash for a majority of this, but still, it's a lot of U's. So another case, Fusion IO just came out with a higher density solution. When was that released?
Last June.
Last June.
A year ago.
Okay, so June a year ago. And so a 6 terabyte solution, again, we're going to use the same chassis. We can get up to 64 terabytes for a 3U server. Now, the price, according to SanDisk, is $2 per gigabyte in bulk. So don't believe the list prices. You never believe the list prices, right? Any of you buy hardware. And still, you'll get very high systems. And this is actually a petabyte in 48U, as opposed to much higher number here. Another example is starting to use 2.5-inch drives. So this is the wide SATA style of configuration, where you use a 2U server that can actually hold 20 to 24 drives in it, which are currently about 1 T in capacity. This is going to get you about the same kind of density as this. So you're saying, Brian, that's really not very dense. To get to a petabyte, this really isn't practical. If I try to talk someone into, talk my boss into this, that's a lot of U to get to a petabyte.
Is that your dollar cost? Those are per year, per fixed cost? What is
Purchase
that?
price.
Oh.
So you're going to have to amortize it yourself. And the flash, the industry is moving so fast. I have customers who have put in systems like this, and they throw them away a year later.
But that's the short tail of the very other long tail of expenses.
Yes, exactly. So the purchase price, I'm going to throw away the power costs for now, right? RAM, the power cost of trying to buy this much RAM is extraordinary, right? So let's just assume that RAM is out of the question for this workload and just talk about what flash is in terms of power. Yes?
For flash, you have utilization costs. Where you have such costs.
Utilization?
Yes. So with security, financial data, you will have to actually support full disposal of those flash drives and security after several goes away, which is quite cool.
It's true. You have to. So the point was that with flash drives, you have to support security, whereas with RAM, once you power it down, it's gone. Right. So that's true. That's an extra cost.
I have a quick question. The P3700, is that the latest one with the NVMe technology? That's supposed to be super fast.
No.
updating with
It's
age
still
stuff? Is it
standard.
AHCI based drives? Because they have the new NVMe, which is supposed to have like super.
Sorry, yes, this is an NVMe based
Yeah.
PCIe drive,
Super
so
fast, yeah.
it's not one of the new. They have people are starting to come out with the 2.5-inch NVMe form factor
Yes.
that'll actually reach this density. But most of the chassis, Supermicro has actually some of them. You get a few NVMe slots, and then the rest are SATA. So you can't actually build out, to my knowledge, I think there's one chassis that I've heard of so far, where you can actually try to put 20 NVMe drives. So that's just barely happening, sort of wide NVMe.
But based on the independent testing they made, the NVMe is super fast. Like IOPS is like crazy on it.
So, yeah, I've been in the Intel labs and
Yes.
run a lot of these tests. We do benchmarks for these guys. And what I'm telling you is a lot of SATA is still really, really, really fast. It's probably faster than your network. So if it's as fast as so you can get almost that performance today out of SATA-based, very wide configurations. There are cases where NVMe exceeds, but honestly, because of network bottlenecks, it's a rare,
That's true.
right? And one of the tricks that I learned from recently from one of our customers who deployed this is the bottleneck becomes the HBA controller, a la the RAID card. Very few RAID cards can keep up with these SATA drives. So if you think the SATA drive is slow, go and check your configuration, check your LSI chip that's on that card, and go make sure it's configured with write caching turned off and fast path turned on. And then maybe try to put 2 or 3 more in them. We find the right balance for the older Intel drives is about 8 SATA drives per controller. If you're going over that, you're probably bottlenecking on the controller. So I think that actually, even though I like the flash industry, I think they're overselling NVMe a little bit. On the other hand, once the drivers for NVMe mature, some people tell me they've matured, some people they tell me they haven't. So they're getting there, right? Maybe they're even there yet.
What kind of networks are you comparing this to? Is this like a 10 gig network or?
Most of the people running these configurations that I know of are running 10 gig. Some of them are switching to 40. A few of them are running things like highly bonded ones. So they might be running 4 ones bonded. But yeah, just simply to get this number of packets in and out is sometimes a challenge. So I saw a lot of 1 gig maybe 2 years ago, and probably in the last year and a half, everyone's deploying 10 now.
It's awful also that.
So I got very excited when I heard about this product from SanDisk called the InfinFlash. What's interesting about the InfinFlash, and Vince will sort of go through that in more detail, is up until now, a flash array from a storage vendor was really expensive. So if you went to EMC and tried to get a storage device, you got all of this enterprise storage stuff. You got reliability, and you got deduplication, and you got compression, and you got volume management, and this other kind of volume management. And guess what? NoSQL doesn't really care. And Hadoop doesn't really care either. These guys partially designed this thing around what does Hadoop need. The way NoSQL and Hadoop deal with data loss and reliability is with more bytes. Give us more bytes. We'll store a copy over here and a copy over here and a copy over here, and we'll figure it all out later. Instead of relying on volume management technology to give you a high level of reliability. Because as we all know, one of the differences in the NoSQL idea is to say, hey, wait a minute, maybe you don't need reliability. We can do it highly reliable, or we can do it not reliable. We can do it immediate consistency, we can do it delayed consistency, whatever you want. Aerospike is a database, like most of the NoSQLs, on a per transaction basis can choose consistency. So why would you put that over a block store that is always highly consistent and is 10 times more expensive? What you should do is get the cheapest bytes you can get and a huge number of them, and then NoSQL and Hadoop will be incredibly happy. And I really want to say thank you to SanDisk for figuring this out, because I went over to their offices and got a product briefing on this, and I walked out with one of my colleagues, and we were like, this is the only company that is really trying to make NoSQL successful. instead of doing everything like, we're going to sell storage for Oracle people, what about storage for the rest of us who have already started switching to NoSQL for all of the reasons I talked about? So let's go through for a minute what this product would look like. Well, first of all, in terms of IOPS per gigabyte, it's lower. Right? So you are getting higher density and lower cost, but you're paying a price because there's no free lunch. Right? The guys at SanDisk have high density or lower density, faster products, as does everyone else. So one thing when you're thinking about flash planning, you have an enormous range of choices in density and performance and price. So you can be almost anywhere on this curve. So this is a 3U system with half a petabyte at well under $1 a gig.
Is that half a terabyte or
Terabyte. It's 512 Gs.
I made a mistake. You told me to fix it. I didn't fix it. I'm an idiot. This is 512T.
Oh, okay, okay, that makes sense.
I'm sorry.
That was wonderful.
This is like the punchline of the slide. So I'm sorry. So yes, 512 terabytes in a 3U. So what this actually is underneath the covers is they've taken 8 terabyte drives that are SAS drives and built a really nice SAS fabric. There are no CPUs in here, right? You go to a Pure Storage or an EMC or any of those guys, they have these big CPUs in there, it's kind of like a SAN head, and they're doing all this crazy stuff, right? These guys just said, look, let's put some bytes in a box and make this great SATA chain, and they're still going to require you to install really decent SAS controllers, SATA controllers in your individual machine. But it's going to be fast. It's pretty fast. It's maybe not as fast as putting it on machine, and they're using a part that's a little bit slower than some of their high-end stuff, but they're selling it for well under $1 and at a density where you can put a petabyte in 6U with incredibly low power consumption. I'm not saying much about power because I don't want to steal your thunder, but the power use here is incredibly low because there's not really anything in the way of CPUs, right? You've got the embedded controllers, but you don't have a SAN head, etc. So to drive 1 million IOPS, I just said, well, for this, I said, well, we could do that about 2 Aerospike servers. And so building this all out in terms of getting a petabyte, you've got 6U of InfinFlash, and let's just call it 8U of Aerospike. Maybe you're going to use 1U servers, maybe you're going to use 2. And now we've got a system where putting a petabyte of flash in your data center is completely reasonable. Okay, you spent $1 million here. So it's not like it's cheap. But compared to, $1 million is something that you can conceive of going to your boss and saying, well, we've got this great machine learning thing where, we are one of the world's biggest transaction processing systems, and, I want to spend $1 million on flash. That's reasonable. That's not, and by the way, the power's not going to be that bad, and I can stick it in a rack. It's not going to be crazy tall. I don't need 200 racks and all the power that drives. So this is the kind of project that you can realistically think of putting together as a budget proposal. So yeah, $1 million per petabyte, and the exciting thing is it's not going to stop here, right? So between all of the chip makers who have announced their roadmaps for 3-dimensional flash and different kinds of NAND, we're seeing even more variation. Some companies are doing different voltages to increase the performance per byte. Some of them are driving down price per byte. But we're going to start seeing even further drops, point by point by point. So we are getting very close to the point where flash drives are price per byte lower than rotational drives. And I think that's what, one of the things SanDisk did was they realized that the Hadoop community is about to shift to flash. And they created a special purpose product to satisfy the market of, if I'm a Hadoop user and I want to switch over to flash and I don't want to pay $10 a gigabyte for a volume manager, what am I going to buy? So we're going to see, it's only going to get better from here. So this is the point where, as I was mentioning before, this is really about getting the cheapest box of bytes for NoSQL, right? instead of spending for enterprise storage managers. Now, this isn't just about NoSQL. Aerospike is optimized from Flash from day one. So what we realized about dealing with Flash was Flash requires parallelism. Every single Flash device, every single one of those Flash chips can be accessed serially, but there's thousands upon thousands of them in a single device. It's like getting a 3-par array on the tip of your finger. And so how would you write code for that? Well, it's got to be multi-threaded. It's got to have the ability to drive queue depths of thousands and thousands and thousands per device, and to do so fairly. How do you do that? Well, one of the things you do is you put together indexes that are in RAM, because RAM-based systems can be made highly concurrent, mostly because of their speed, right? You've got, besides building lock-free algorithms, which you can do in any storage device, RAM is simply faster, so you can get more threads going through, and the sharing of it is easier. So by having a highly parallel system, multi-threaded, written in C, we can actually drive Flash to the performance of Flash itself, and not require, like say, a CPU-bound system like Cassandra, a lot more servers. So compared to Cassandra, we've really found that we can drive down often a 5x server reduction simply because we're lighter on CPU. The other thing that we've actually done is, with our experience in ad tech, we've had literally 5.9 reliability with multiple customers. I picked our longest running cluster, which is, as David mentioned, over at AppNexus, and to my knowledge, it's had 5 minutes of outage with no maintenance windows. They have done 4 forklift upgrades, switching from one generation of hardware to the next without any service downtime. You just start slotting in new cluster members, and then basically you retire the old equipment without any downtime. They do it in production. So we're pretty proud of that, and we think that this kind of NoSQL use that I'm talking about in fraud detection is a great case for this, right? You still need the kind of reliability. You can't just take that kind of system offline, as well as we provide the enterprise support. And what we mean by enterprise support is, if you've got a problem, we'll fly engineers out. We did this recently for a Southern California company, Rubicon. We were in the middle of getting some stuff going in a new project, and they said that they had performance problems, blah, blah, blah. And finally, after like a week of going back and forth, we said, okay, guys, you're in Southern California, we're in Northern California, we'll fly down. We flew down 4 engineers, and over the course of about a day and a half, sorted them all out. And it turned out it was primarily a misconfigured rate card.
Wow.
Right?
Wow.
But on the other hand, they needed it now, right? There's a guy whose job is on the line. He chose Aerospike, and we wanted to make him successful. We wanted the entire deployment, so it's not hands off. And so we like to be the company that provides that kind of support to the people who use Aerospike. Or, hey, it's open source. The whole thing's open source. We have 4 features in the enterprise version, which is cross data center replication, security and login, and a particular form of restarting for operations. But honestly, it's the support that people really get value for. Being able to start a POC with the right hardware, get the right kind of performance, is what people pay for. So we're starting to see these kinds of uses in financial services. We're starting to see the model of computation where the app server is driving compute instead of the database. And we're starting to see that go into multiple different industries, coming partially from the work that had been done in ad tech and moving out from there. So I'm going to turn, okay, 1 or 2 questions. Sir?
Quick question. Cassandra allows you to do associations in your NoSQL queries and using query loosely. Can you do NoSQL, or can you do associations in Aerospike?
No. Which is to say you can do it, but I don't recommend it. Our strength is really key value, as opposed to that kind of query system. So we do have an aggregation framework, and we can support it. We have things like the Hadoop and Spark connectors to allow you to run Spark SQL, but it's not very fast. What I'm telling you here is, the point I'm making is really for an operational database, key value is almost always the right answer. So yeah, we support it, but don't do it in production. Yes?
Speaking about high availability, when you said that 1 petabyte plus 1 million, it means like physical petabyte. But in terms of logical petabyte, when you need to organize some really high availability, wouldn't you need like 3 machines like that?
Yes, good question. So at Aerospike, we don't believe in this idea that you need 3 copies. So unlike Hadoop and Cassandra, and so part of the philosophy in with 3 copies is if you're going to vote, you always need an odd number, and that's just wrong. Not that I'm opinionated about these things, but just because 2 people agree and 1 person disagrees, that doesn't mean 2 people are right. What you actually need is a transaction commit system, and you need to have a replica of that, and you need to have transaction logs so you know who is right. Simply throwing 3 copies of the problem doesn't get you the correctness. So most of our large deployments run with 2 copies. So yeah, you still but that was a little diversion. So yes, so Petabyte is raw. You also need essentially compaction overhead like Cassandra, because the database has to do real-time defragmentation of the block store. It's an entirely different talk about how to get around the block store problem. I think I gave it here a couple of years ago about using key value interfaces and storage and new storage interfaces. So between compaction and 2 copies, Petabyte probably Petabyte of raw turns into about 300 terabytes.
Here there's many problems. There are different points of failure when you design such a huge array, and one of them is simply hardware failure. And I'm not speaking about SanDisk, a good company. It's a hardware. It may fail, and it's only 1 piece. And here, the real risk of losing everything, because you already invested 1 million. If you're able to invest 1 million, then you won't have some security.
Right, so you clearly need to walk through where your failure points are. And maybe you can answer some of this stuff, but one of the points about this is the price really is mostly price per byte and very little price for the chassis. So if you want to break it into 2 different failure cases, buy 2 of them and half populate them. Right, so nobody would ever recommend, well, I wouldn't recommend putting in just 1 chassis for an HA system. That's crazy. But having 2 chassis, or even 4 that are half populated with one Aerospike in front of it, you're starting to get up to the hardware counts that I think actually provide HA in my experience.
We've also done some studies on the reliability of Flash, which has increased dramatically over the years. And we're really at the point now where a flash drive is probably about 10 times more reliable than a disk. So if you're experiencing 1/10 of the failures, you don't have nearly as many rebuilds going on, and that's another reason why you don't need a triple redundancy. Right? Because you're not eating up a lot of your network bandwidth during repopulating replicas after a failure. And also, you don't have that exposure window that you do with disk drives. You've got multiple failures occurring all the time. You've got a 100 petabyte deployment. You're going to be running around a roller skate changing drives, disk drives. Where we actually anticipate with one of these InfinFlash devices that you'll experience about 1 failure a year.
How about replacement? What is usual replacement time from Reliable?
They're all hot
Could you repeat the question, please?
Yes, the question is how fast you get those arrays replacement. Because you have 2 of them in production, 1 is down, and how much time it takes to replace it?
Well, it's a fully redundant system, so the entire system is highly unlikely that it would go down entirely, the entire shelf. What you'll lose is an ice chip card. It's one of the SSDs that are internal to it.
Oh, so it's big chassis with lots of...
Yeah, well, sure.
Yeah.
Okay, well, we'll get to that. So why don't I get going on this? So big data flash from SanDisk. So SanDisk, you're all thinking, I sense what you're thinking here, consumer products. But actually, over the last couple of years, we've expanded dramatically. Over the last 5 years, they've really picked up a tremendous number of companies in the enterprise space that really wanted to get into enterprise storage. Because SanDisk realized that now is the time where the performance, reliability, and cost of flash is really applicable to enterprises, and where it's going to be not something that's just for 5% of my data, but in the next 2 years will be for all of my data. Right? Disk drives are going bye-bye. We just released a 2 terabyte SATA drive that is actually being offered by major OEMs at the same price of a 2 terabyte spinning disk. So they're not going to be selling a lot of disks anymore because they're a lot slower and they fail more often. Why would you buy one if it's the same price, right? So SanDisk is all about Flash. We've got 5,000 patents on Flash. We don't sell anything but Flash. Right? We're vertically integrated. We have our own fab. We make our own Flash. The reasons why we can offer maybe a little bit cheaper than some of the other competitors out there. We've got a number of recent enterprise firsts, like the first to market with DDR storage. With the acquisition of Fusion.io, we were first to market with PCIe. I'm a market leader in there. We've got first to market with larger enterprise SSDs. We're supported by the major OEMs. We've got a lot of major OEMs. But nobody knows that we're in the disk array because they're labeled, they slap an HP label on and stick in the 3-part array. Or slap an EMC label on and stick in the EMC array. Right? So SanDisk is actually a little bit more than just thumb drives now. We're SATA SSDs, SAS SSDs, PCIe cards, DDR RAM, DDR flash memory. All flash arrays, really high performance, lower density all flash arrays. And this InfinFlash gadget. We don't make TVs. We make one product, we make flash memory. We're not a conglomerate that makes everything from TVs to, rockets. We make flash memory. So we're very well focused on the market. Okay, so we've noticed a trend, and as Brian was saying, we noticed a trend that there's a gigantic hole in the market that nobody's addressing. What do you do with big data? Everybody's thinking, oh, just throw out 100 servers out there and throw 2 drives in each one. And then they go, gee, the performance is pitiful. As soon as you load it up, it's great when you've got one client on it. You get a couple thousand machines beating it up, it's all of a sudden it's pitiful. Like everything's taking 500 milliseconds, it's just absolutely terrible. So Flash is really the answer to getting responsiveness out of a scale-out architecture. So where we see this happening and being really useful is in content repositories where you're storing large key value stores and things like that. You can be doing analytics, big data like Hadoop, NoSQL, or media services and streaming things like music, TV, movies, that kind of thing, where you need a consistent bit stream coming off of it that you can't get from disk drives because the heads are moving around like this all the time. And you never get a consistent bit stream out of it. Where with flash memory, you can take thousands of concurrent, consistent bit streams out of it at the same time. So it gives you a different type of performance than you're able to achieve with disk drives today. So we also thought we can do better than what's out there today. So what did we thought about? We said scaling out really requires capacity and high density because what we don't have today is density with the disk drives that we have today. Right? You need performance when you need it. It's got to be there when you need it, especially at peak times. Low operating costs, which is power and cooling, and simplicity. You got to make it easy to use. It's complicated. It's not, right? And with some kind of quality of service. You have to be able to guarantee that certain things are going to be able to get done. If you say it's got to be, that's more important that it gets done. So we came up with InfinFlash. Now, what it is it's architected, particularly for massive scale out. It's that really high density, that 512 terabytes per 3U. Right? It's a new flash form factor. It's not SSD based. Sort of. What we did is, since we own the technology for making the SSDs, we bought a couple of SSD companies like Smart and Pliant. Right? So we own the control technology, we own the flash, and we don't have to have it in a 2.5-inch form factor. So we splayed it out and loaded it up with flash, 8 terabytes per card. And the cards fit in a chassis, which I'll show you in a minute. So it gives us a more compelling TCO because there's less packaging involved, so we can actually manufacture these in a cheaper way. So compared to traditional approaches, it's just like way higher density, way faster, way more reliable. Just everything, hands down, there's not an attribute you can't say that it's not better in. Except maybe price. Okay, so this is the InfinFlash unit, a nice architectural drawing of it. What you've got here is, redundant power supplies, redundant fans. These are redundant SAS interconnects, and then a bank of the SAS flash memory. So you get 64 8-terabyte cards, all with enterprise features like PowerFell backup, so that if it loses power, it's not going to trash your data. It's a real enterprise type drive. It's got, of course, the wear leveling and high endurance that we expect to find in any kind of enterprise drive today. Performance, with that many of them, even though they're not, the most highest performing drives we make, since they are a lot of flash per drive. 8 terabytes. The typical we're seeing out there now is 2. Right? We just came out with a 4 terabyte drive, SAS drive. This is twice the capacity of that. So this is the highest density SAS drive in the market today. Right? So, and of course, the performance is going to be a little lower, but since you're at there's power in numbers. So we're able to spread the load across a whole bunch of them. You get 780,000 IOPS at under 4 milliseconds, and that's at the 4 milliseconds is at 780,000. Right? 6 to 9 gigs worth of throughput for large blocks of content. Right? All hot swappable. The cards are hot swappable. The fans are hot swappable. The power supplies are hot swappable. The interconnects are all hot swappable. So if it dies, slide it out of the rack, pull the cover off, and all these nice little ice chip cards we call them. Code name is Big Blue. These cards, they have alerting and monitoring, and they have little lights on them. That if it's failed, it'll have a red light, and you just pick one with a red light, pull the tabs up, yank it out, replace it with a new one, close it, cover it back on, slide it back in. The database or the application, be it Ceph, Cassandra, Aerospike, whatever your big data application is going to handle the redundancy and repopulating that one ice chip that failed from the remaining packets.
Real quick question. In controller, are you guys using your own controller or using third-party controller like SanDisk or something?
This is our own controller.
Your own controller.
Right, so that came from Smart, actually.
Okay.
Right. So we've got within the chassis, there's all full chassis monitoring within this. The trick is that this is SAS connected. There are no controllers. There's no CPUs in there. There's nothing fancy. It's very simple and inexpensive. 85% of the cost of this unit is the flash memory. Right? So,
What's the cost? What's the cost?
What's the cost? It's under $1 a gig.
Well,
So a 512 terabyte unit would be about $512,000.
sure.
You buy in bulk, you get better pricing. You'd be surprised. eBay's gobbling these things up by 10 at a clip.
Oh, really?
So,
Wow.
yeah. So those kind of places, they look for that kind of stuff. That's what they want.
You see this landing in intelligence and snoops?
Yeah, absolutely. Most of it they're on Fusion IO cards right now. So they're scamming all your emails and
What about genetic speed?
our technology.
What about genetic speed?
Yeah, there's some interest from genetics. Structural Biology Center in New York here is talking to us about deploying some of these units. But they're relatively new. They've only really been out for about 5 months. So, we haven't got a heap of deployments yet, but they're getting a lot of interest. A lot of the banks in New York have got POCs in progress. They make a great long-term repository. See, it only pulls 30 watts in sleep mode. 750 watts maximum. Typical running is about 400 watts. It's less than the computer that it's connected to. Try doing that with a petabyte of disk drives.
What is that TBF?
Mean time between failures?
Huh?
Mean time between failures.
So it's not like after 1.5 million, it's just gonna close out.
No.
To make you upgrade.
No.
Buy,
No, it'll run, it's got an anticipated 10-year lifespan.
Oh, yeah.
Right, so the in-chassis solutions talked about before, 48U for the Supermicro with the Fusion IO cards, with the 6.4 terabyte cards. We're finding that people want more density, not more performance. These perform about the same as the Intel B3700, maybe a little bit better, but they're 6 terabytes, not 2. So you can get 64 terabytes at chassis instead of 20. So people are finding a lot of value in that, and we actually stopped making anything less than a terabyte in cards. We don't make a 200 gig one because nobody wanted it. Nobody bought them, right? So we can get a petabyte at 48U in that, and with the 2 terabyte SATAs, we can do it at 50. So that's also an option. But the out of chassis experience will get you 2 2U servers with 512 petabytes and a whole petabyte with 14U. So it's about with the Aerospike service. And it's a simple, there are 8 SAS connections on the machine, so you can take 2 servers, 4 SAS connections each, and plug it in. Very simple, simple, elegant solution. And that's it. So any further questions?
Yes, that's Eric's line, but.
Well, yeah, okay, you took the line. Any further questions?
Well, yeah, I did.
I want to give a great big thank you to our speakers of the evening. And Brian, we'll take any, actually either of them, I guess we'll take any questions. Yeah, hands up. You can see who that. Everyone's pointing to this direction. Okay, you get it.
Here's this question. Of course, what we hear about is using Flash for big data and so on and so on. And of course, it's the most important, the most needed, for what we are looking at usage. But at the same time, it's also used. Flash is also used for very, very smaller things. And let's take today, if you want to buy like a laptop, desktop, something like that, you have options, either regular, spinning drive, or SSD, or effectively flash drive. Now, if you look at price of that today, and my main question really, I switch back in a moment. Main question is when this is going to leave. Today, you will pay a few times more for a few times smaller SSD than just spinning drive. Today, if you want to buy it.
Yeah,
how soon it will change? Because it will be just showing how overall prices change, and not only prices, and especially for big data, but when this is going to happen. By the way, also, if you pay $1 per gigabyte, if you want to buy like laptop or desktop with 1 terabyte, let's say, you still pay $1,000 for just drive.
Well, yeah, that's the difference between enterprise drives, which are about $1 a gig, and consumer drives, which are more like 60 cents a gig.
See, less than the one.
The consumer ones are a lot cheaper, so the things for your desktops and your laptops are going to be a lot cheaper. But a large portion of the difference is the amount of controller technology that's in there, and also the power fail protection. Your laptop, you really don't need power fail on your SSD because you've got a battery on your laptop.
What about desktop?
Same thing with the desktop.
How many people here own a desktop computer?
Yes, I am.
Okay, 5. Okay, now the second question. How many of you have a laptop with a rotational drive? Okay, you guys, you 5, you need to respect yourselves. When you switch, you will be more productive. Your work will be better. Okay, if it's a work laptop and it has the work laptop sticker on it, maybe you just need to change employers. But most of the people here are using Flash. Their boot times are shorter. Everything they do is shorter because they respect themselves. And I believe in you guys. So you don't want to Okay, good. Let's go.
I'm working on it. There you go.
Next time, buy it.
So are you giving away SSDs today? Is that
But for professionals, that's a home market. For professionals like us here, you should be on Flash on a laptop, and you should have switched years ago.
Before we continue, I just want to point out we are giving away a $100 Amazon gift card. If anyone has not had a chance to fill out the form to enter, either hand the form to him or ask him for a form.
Which would allow you to buy a SSD for your laptop.
There you go.
All right, you had your
Good one.
minute.
Today.
Yeah, so this is
this question is kind of about the, maybe a little bit dated, but about the SSDs. In the early days, they would sort of wear out. The read writes would be a problem, and particularly for database I/O intensive applications, it would be a problem potentially, right? And so is that still a concern, or do you feel like that's been addressed? With
no, it's been pretty well addressed. Fusion.io actually did a lot of pioneering in that, in how to actually treat the flash media itself, because they really understood the difference between disk and flash, and how you can't just treat flash like disk. So what early SSD manufacturers really didn't understand this, what they did was, if a data block got overwritten, it would actually write the data on top of it. Fusion.io said, that makes absolutely no sense. So what they did was they structured it like a log structured file system, and they kept a couple of queues. So you've got a queue of pre-erased blocks that are ready to be written to, a queue of blocks which were recycled, and then a queue of writes that are coming in. As the writes come in, you tack them onto the end of and you write them to the free space, and then the stuff that gets recycled gets erased, right? So it's this marching step where you go through, and every time you go to overwrite a block, it just marks it invalid and writes it somewhere else. So very much like a WAF to file system, or you've heard of.
So it turns out that an old buddy of mine was Flynn from founded Fusion.io. So I went over one day, and he explained all this to me, and I said, well, I should do my database the same way, which is what we did. And this is one of the tricks to what Aerospike does. All of this is reducing write amplification. So at an OS layer for software guys, if you write to a file system, and that file system has to update a couple of different things and do something in place, and then that's actually writing to a block store that's doing the cache invalidate, blah, 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 that's where you get write amplification. So writing a 1 byte in most operating systems will invalidate 7 blocks on flash. That's death. If you do it the right way as a database and as a card, write amplification almost vanishes. And that's why we typically have had, even for the flash devices from a few years ago, no failures to speak of. We've had failures due to bad controllers and using some consumer grade parts that were not appropriate for the use. But in terms of actual write failures, I can't think of one across probably 50 to 60 of our very large scale customers, each one with hundreds and hundreds of drives in production for years.
There are a couple other problems. I mean, if you overwrite the same block, you can write to a piece of flash memory like 3,000 times, right?
Right.
If you're overwriting the same block again and again and again, because it's a super block and you have to update it all the time, if the SSD actually writes to that same block that many times, it's going to wear it out. And then it's sparing, or in the early days, they didn't know how to do that. It just failed. So they would fail in like 6 months,
But if you write to a new place, instead of just writing in one place, again, let's forget for a moment what you just said. I'm looking for different point of view. Maybe we should make it more complex, not to write a million or billion times in the same place, but just if we write everything hundreds or thousands of times, it will sustain it definitely. Instead of just overwriting in one place, we have to go to 2 places. In one place we mark it as not existing. In the other place we write. It should be twice slower than just writing in the same place.
Actually, we keep a block map in RAM, either on the device or in the operating system, depending on the device. And to invalidate, you get flip a bit. It's a block map showing what's on the flash.
In the RAM
In the
or
RAM.
flash drive?
In the RAM, and then you write to the end of the log. That's
Yes,
where the new write goes.
But
Let's move on. This all works. This is technology. Talk to us about it later. This is 5-year-old technology.
Yeah.
We'll talk offline.
I'm not arguing.
Let's take the next
We'll have
question.
to talk.
I
Yep.
want to know.
I can send you some white papers.
Does Aerospike
Okay.
support the SQL queries? Should you
Let's send
need
me
to
a note.
use them?
We have some SQL support. We will be adding SQL support. There's been a lot of talk at Mongo World this week in New York, as well as at Couch's Summit. I think finally we are getting to what I call no-SQL. So if NoSQL was not only SQL, then no-SQL is not only no-SQL. So no, there are cases where SQL, you either have to do a legacy integration, right? And maybe it's okay that it's a little bit slower. And so all of us are adding SQL, we're doing it too.
is addressed to the gentleman from SanDisk. So, knowing that the cost per storage is going to decline as quickly as it is, and knowing presumably, I'm going to assume that the R&D dollars are really being dumped into semiconductor storage as opposed to aerial densities and magnetics, when is the assumption that we're really going to stop seeing widespread, in essence, availability of spinning media? What is SanDisk's position on this?
We are already seeing a significant drop off in the ordering of 15,000 RPM drives because they just don't make sense anymore. People just stop buying them. So it's just a matter of the EMCs of the world, just realizing this as well. And they are. I mean, they predominantly they're selling more systems with some flash drives and a bunch of slower spinning drives that are like 7,200 RPM rather than 15,000 RPM. The next step would be the 10,000 RPM drive and thereafter. Since the disk drive densities are not really gaining all that much, they're at about 6 terabytes now. As the flash memory cards and SSDs surpass the density that we're able to get in spinning media, which should be sometime in 2016. As 3D NAND takes off, we're going to double the density in the same capacity. So our 6.4 terabyte cards can be 12 terabytes. Our 4 terabyte SSD is going to be 8 terabytes. Everything's going to double in capacity. As soon as we do that, it doesn't even make sense to, if we can get the dollar per gig down, it doesn't make sense to buy spinning media anymore.
Does SanDisk have any investment in R&D for something other than multi-level flash storage stuff?
Oh yeah, absolutely. Yeah, we're building a new fab to produce 3D NAND. It's they broke ground on it last year, and it'll be ready sometime around December.
In the States?
It's in Japan, of course.
Might be Singapore.
Might be Singapore. But we do have plants, all over the U.S. and also all over Asia. We have assembly plants in China, Malaysia, and
That's
we actually
device-
wafer manufacturing in Japan.
That's device geometry in a flash system, is it not?
Yeah.
Is SanDisk having interest in like memristors and things like that?
Yeah, absolutely.
Okay.
Yeah, we have ongoing research and development of memristors and phase change memory, and we're always looking forward to what's the next.
Yeah.
So this was a quote I heard at a conference a couple of years ago, that big data, and these days big data means petabyte data, is like teenage sex. Everybody's talking about it, everybody claims to be doing it, but very few people are actually doing it. And so I used to do real big data. I don't do big data anymore. I do reasonable data. And so do you have products that are more 100 terabyte scale, 50 terabyte scale products?
Well, this unit's actually available with as few as 8 drives, so that's 64 terabytes.
Okay.
And then you can build it out as you go. You don't have to buy it as 512.
Okay.
And from an Aerospike perspective, the in-chassis solution starts looking attractive there, right? Once you start talking about a 1 terabyte drive, and I've got some guys in San Francisco, they've just put 2 1 terabyte drives in a server. They're Cassandra guys, and they need a lot more CPU than storage. So there's different configurations, but basically just starting with a couple of those works great. I mean, I have a 1 terabyte laptop, a flash drive, that computer there, right? So I do all my development on that.
Yeah, I mean, we're looking at 50 to 200 terabytes of data here. So, okay.
Yeah, so it scales back, but you can also use the in-chassis, especially with something like Aerospike, which is low CPU overhead.
And the per GB cost stays the same, or does it change?
It's slightly higher because it's more chassis and less flash.
Mm-hmm.
But the chassis is the cheap part.
Right, so you think about it like this curve. Every chip, there's difference in speeds in chips. There's different controllers and how many controllers to flash chips. That's going to change your speed. And then there's CPU to storage devices. So you've got like 3 axes to be able to change performance versus price.
True, and so something, a product like this, is this available in a cloud offering that I could sign up tonight and start playing with it tomorrow?
Yes.
Okay.
Yeah, we have demo
So
systems.
I'd be
ship
interested
onto your
in
site.
checking that out.
There's a question for you. I mean, recently there was a report from the JDEEC regarding the flash storage. Like if it drops up under a certain temperature, especially for cold storage, like the data dries out or something happens to it. Is there something you can confirm or?
You do have to continually power flash memory because otherwise it'll start getting bit rot after 3 months of being powered off. So all those old USB card drives you have, They're subject to bit rot after 3 months. Don't leave stuff on them. You know, you want to put it on an SSD in your house, or a server or something, move it up to the cloud, make backups of it elsewhere. USB drives themselves are not, you know, not terribly reliable. And the same thing goes for these things. We guarantee that they'll maintain your data for 3 months only if they're powered off.
So what's a better way to store it?
Cold storage, really unpowered cold storage.
How about
So I own a
rotating disks?
generator at my house, and I fire it off every 3 months. You know, just in case there's a massive power outage and the zombies take over, I can still actually power my flash devices. Once
That's
every
where
3
Tesla
months.
comes in.
If I just have that, yeah, or just plug it into your Tesla. just for a few minutes every 3 months. That's it.
Would rotating disks stop that problem? The long-term storage, putting it on rotating disks then?
No, they're subject to bit rot as well because the actual media is, you know, it's, you know, basically rust on a platter, and that degrades over time as well, right? The magnetics of it. So the best thing you can do is at only like 40, only 40 watts of power.
DLT 2000. Yes.
Blu-ray.
Having a petabyte of storage in sleep mode at 40 watts is pretty reasonable because it's less than a light bulb. You know. So.
With a flash drive, you have to power every 3 months.
At least every 3 months you have to go.
Only if you want to do it.
You don't have to do anything.
You know,
You just sit at home
the
and drink
media
beer.
itself is, you know, it gets so small, we're stuffing like 4 electrons in there now, okay? In a little hole in the silicon, right? So, you know, if it sits for too long without power, it tends to lose that, and they start getting bit rot, where the actual electrons will jump ship and jump into the cell next to it. So, you know, there's a lot of ECC that we employ in maintaining your data.
By the way, if we power it 24/7 all the time, are they good or they also become bad?
No, those are good.
Especially, I mean, big arrays.
Yeah, the controllers actually do care and feeding of the NAND. What they'll do is they'll actually take stuff that hasn't been touched in a while and they'll move it every once in a while. All right, just to make sure it doesn't get too much bit rot from sitting around. So that's one of the reasons why you power the system, is that the controller is actually active all the time. If you're not writing to it, it's going like this behind the scenes, you know, moving things around. And we also characterize the NAND because NAND is actually quite flaky. So even on a single chip, some of the bits will be more reliable than others, right? So we may be rated at 3,000 PE cycles, or program array cycles. But some of the cells will actually be good for about 20,000, other ones will be good for about 500. So what we do is, as you start using it, and it starts using the media, the controller tracks how good the cells are, and what it'll do is start taking your cold data and migrating it onto the crummy cells, and then keeping your hot data, the stuff you're writing to, on the higher endurance cells. So it actually wear levels it a lot higher, and we get much higher endurance out of our products.
We got time for like 1 or 2 more questions. Yes.
1.5 million hours between failures.
Yes.
It's a lot of hours. It's approximately 170 years. The question is, how that statistic was gathered?
The usual
Just the
way.
way.
You get 10 of these things, you put them in a room, and then you only have to test it for 17 years.
Yes.
Yeah, based on the number of failures that we're seeing, because you do get infant mortality and things like that. And it's also based on usually standard, IEEE standardized ways of determining failure rates on what the failure rates are on the controller chip, what the failure rates are on the NAND chips, how much extra NAND we have per SSD. Because we do pack on at least 20% more NAND on it than we tell you is there. So a 1 terabyte drive is actually 1.2. And so that gives us a couple hundred gigs to plug back in if something fails, right? And so these things extend the lead time between fires, and so we can anticipate, extrapolate forward.
Okay, last question of the evening. Yes.
Yeah, so this is a question for those people who have personal laptops and we have sometimes that hard disk is crashed or something. Do you have any tool which is better to recover those bad sectors or drive or something? I'm not talking about those corporate who has like cluster server load balance with 7 active passive node and they have everything. But for those people who have just 1 laptop, I sometimes sync my backup and I don't do anything, but sometimes it crashes and it says, oh, nothing is there, what to do?
Yeah.
So any software which is like which is developed by SanDisk, which is better to recover those bad sectors and at least get some data out of it.
No.
No.
Next question.
Well, actually, once the controller is dead, that's it. You can't recover your data from the flash drive.
No, you can pull the chips out, move it into another system, just like we used to do with tape drives. When the tape got creased, you pull it out, you stretch it out, put it back in, put it back out, and do it, right? Same thing
But
you do with
I
ladders.
actually gave
Same
that
thing
to
with chips.
one of our clients had a failed flash drive, like basically an SSD. It's an Intel based, and we give to like a data center, like expert recovery, professional recovery, whatever forensics. They charge you like $5 grand, $7 grand. They don't even recover. Oh, it's dead, it's dead.
But still they charge. But still they say that we tried, 5,000 is not there.
So if you will unplug them from one chases, from one server and plug to other server, how database will know that that data is there?
Yeah, so we support doing hot plugs like that, both adding new drives and actually moving things from place to place. So what we do is we write a header on the front of the drive. We've got everything partitioned out according to our distributed hash table. So you take something out of one drive and put it in a different machine. We read through the header, figure out what data might be there, and then have to sort of go sort things out. Usually, though, if you do something like that, you've already got a second copy. And the right thing to do is actually ignore the incoming copy of blank drive and actually take it from your replica, which just got promoted. So it's not that hard, right?
Okay, we're about to give away a $100 Amazon gift card. Before we do, I want to give a great big round of applause to our speakers of the evening. And let's see who wins this. Oh, by the way, both of our speakers are here for one-on-one questions afterwards. So anyone who did not get a question, feel free to come up right after this raffle. And I'm trying to do this like a deck of cards. It's more challenging than it looks. Please reach in and just grab one sheet out, just one. And read it out loud, the name? Just the name.
Sure.
Yeah, that one's a
That's
hard
my name.
In all fairness, everyone, I was standing here shuffling them. There's no way she could have done it. She won. That's the first time it's ever happened. And I was standing in front of everyone shuffling them back and forth. Thank you all for coming.
Thanks a lot.